Welcome to this short video on what's new in GenFEA build version 12 September 2024. Now, I'll just open up an example model here so we can quickly have a run through and see what has changed since the previous versions of GenFEA. First, we look at the meshing components for shell elements in GenFEA. So we can see that we've got a pretty decent quality quadrilateral mesh here in the model. And what I'm going to do is I'm going to quickly remove the existing mesh. So we're going to choose clear mesh, and I'm going to draw in a little bit more complex geometry. So we'll adjust our grid settings and then create two openings in the lower and the upper shell element. And then we'll use the draw shell tools and toggle our grid snaps and joint snaps so that we can easily create those vertical shell components, as you can see. Right, so now that we have completed drawing in our example shaft walls here, we can head over to the mesh tool and we can click generate using just the default settings. And what this is going to do is give us a preview of the mesh that is going to be generated. We can see this is a pretty decent quality quad mesh, but not exactly structured. So we can use the structured optimization button, hit generate again, and without bringing the elements back into the model and splitting or discretizing the connected elements, we can first have a preview on what that result is going to look like. And we can see this is a pretty decent output. If we wanted to adjust the mesh size and see what that looks like, we can do that. And if we wanted to specify some custom values here, of course, we can do that. And let's specify a mesh sizing factor of 1.2 between the smaller and the larger meshes. Once we are happy with the result, we click on apply, and that brings the mesh back into the master model. And now the discretization and splitting of elements and reconnecting them back in is all going to happen automatically. Right, so we can see there we now have our updated model, and I might just want to reset my grid to its original position. And if we want, we can adjust the grid size again back to 1 meter intervals. And it's as easy as that. At any point, if you wanted to change the mesh, you can simply head over and click on the mesh tool button. If you have existing mesh in the model, it's going to warn that the mesh will be cleared. We can say yes, and we can go ahead and generate the mesh again. So if we want 500 by 500 minimum and maximum mesh, we can hit apply, choose the structured optimization, and see the results. And then, of course, just like before, we bring the mesh in, the discretization happens automatically, and we have the result. And there you have it. So now we've got our meshed model, and if we just quickly want to run an analysis and make sure everything works, we can go ahead and do that. So we let the analysis run through, and once it's loaded, you'll see those discretized elements appearing in the model, and we're ready to view the results. Right, so when that's completed, we can specify the case that we want to load. I'll just leave it as the default for now for this example, and we'll switch on our results. Let's just close up this context ribbon menu, and we can see we've got our results plotted in the screen for deflection. The next part is showing the values. So we've improved the labeling and display of values. So by adding a leader, it just makes it a little bit easier to read and distinguish when you've got multiple objects on top of each other, such as the case is here. And if we want to view forces in the model or stresses and moments within the slabs, of course, you can switch those on. And we now display the maximum values when the labels are switched on the shell elements also. Now, the next part is the reporting. We've created some significant updates in reporting, and all of the reporting tools are now available right inside of DesignPad. So in DesignPad, if you click on the report generative tool, we can specify the output results, what we want to see in our report from the analysis results. And when we hit OK, it'll go ahead and generate the report script for us. So there you have it. We can see that the report has now been generated. And if we look at the outputs, this is what we see. So very clear, very detailed, represents really well all of the various analytical outputs in the model displayed here. Now, what if we wanted to add information to our design report, such as design components? So we see the analytical report here, but what if we wanted to see some design components? Now, this is where it gets interesting. You can either use the scripting tools directly inside of DesignPad to add components. So let's say we wanted to add a section here with an HTML tag and a new heading. So we'll click on the heading tool there. You'll see that it'll place this in the report, and we can call this one, let's say, steel column design. Now, if we head over here to our report, you'll see that once we click on an empty line, that'll be added. Now, understanding the HTML scripting for DesignPad might be a little bit of a learning curve. So what we've gone and done is we've included the instructions to DesignMate. So that means we can actually connect to DesignMate, and this brings us to the next part. DesignMate is now not run locally anymore, which required a node server to run and slower response speeds. It's now completely online, but your information is obviously still saved. But using the new DesignMate, it means that we can run our design. So let's say we want to select those steel columns. We want to prime the LLM with the information on the model and run a design using our templates. So an example template here's on the steel design. Remember, you can build up your own templates, meaning you can design pretty much anything to any international design standard. But let's say we use one of the existing ones, the steel member verification. So we'll use the steel member verification. I'm going to say here, assume values based on standard and location, prelim design. So we could enter static values here or whatever it is that we've set up in our template, but I'm just going to tell it to use some assume values and then start generating that design output for us. Now let's see what it is doing. Okay, so we can see that it has done a member verification. It's included some checks for bending capacity, shear capacity, deflection compliance, lateral torsional buckling capacity, etc. It's telling us that it's assuming compliant if the section is compact, because we haven't specified all of those required factors. But of course, if we adjust our template, again, if you want to adjust any of these templates and the way they work, you can access them and change the input parameters, the variables that will be fed into it, and these are live templates, so they can update. And this forms the instruction that is sent to DesignMate. In any case, now that we've got the output, let's say we want to include this in our design report. So what we can do here is go to the miscellaneous design and choose the DesignPad generator. We click on send, and what this is going to do is we'll send the instruction to DesignMate to create the script for this particular output. And all we need to do is to click on copy code, head back to DesignPad, and then we just paste the code in the relevant location. So just place that in there, and we can see if we scroll down now, we've got the steel beam verification components here. And if we wanted to change anything, of course, we can just click on the arrow to take us to the relevant section within the HTML code of our report. So this means you can generate reports combining analytical and design information, and you've got full control over the whole process. Right. Thank you for watching, and if you found this interesting and informational and you wanted to give GenFEA a try, download it and request a try license now. Thanks, and talk to you soon. Goodbye.